We have a jet is moving along an airport runway. At an instant it passes a marker. It begins to accelerate to take off. From the time the jet passes the marker, its distance from the marker is given by s equals 2t squared plus 3t. Now let me explain what's happening here, okay? If we do an s time graph, okay, so distance on the x-axis, t on the y-axis, we go to the calculator. Now, what time does time have to start at again? 0. So instead of using t squared, I'm going to use 2x squared plus 3x. I can't use t on this calculator, okay? Start at 0, I don't know, end at 10, okay? Step of 1. Now look at our points, okay? 0, 0, 1, 5. 0, 0 is around here, okay? And I'll call that 1, 2, 3, 4, 5, okay? And then the calculator itself, it starts to get really big, doesn't it? Like it goes up, it's like 27, 44, all the way to 90 very quickly, okay? So what I'm going to do is I'm just going to scale it like this: 10, 20, 30, 40, 50, and 60. Now I just want to do a quick, like a rough diagram of what's going on. Starts off at 0, 0. What does this mean? At time equals 0, it has travelled no distance. Does that make sense? Yeah. Everybody happy with that? Sam, get off your phone. Okay. Next thing. Next one after that is 1, 5. What does 1, 5 mean? Anybody? 1, 5. After 1 second, it's travelled 5 meters. What does 2:14 mean? 2 seconds, it's travelled 14. It's up here. And then after 3 seconds, 27. So 3 all the way up to 27. And then finally after 4 seconds, it travels 44 meters. Okay. So guys, remember, can anybody in the class tell me what shape is this equation? U-shaped curve, okay? So what happens is, it's a U-shaped curve, however, you only have one side of the U. The other side of the U isn't there. So what this is describing is an object that's getting faster all the time. The faster it gets, the more quickly it gets away from its starting off point. So you can see that it's going to get steeper and steeper. Its basis slope's going to get steeper and steeper and steeper because you're increasing your distance faster and faster and faster, okay? That's why it's a U-shaped curve. Everybody alright with that? Yeah, eventually, if they're going so fast, that'll appear near enough straight up according to your diagram. Now, find the speed of the jet at the instant it passes marker T. Is a distance equation or speed equation? It says in the S is a distance question. What does that mean about the first derivative, lads? First derivative is the speed, which is 4t plus 3. And it wants me to plug in which value of t? 0. 4 times 0 plus 3? It's going 3. Now, is this meters per second or kilometers per second or what is it? I think we're going to say it's meters per second because it's moving along. It says meters and time is in seconds. 3 meters per second. The jet has to reach a speed of 83 meters per second. After how many seconds will it reach this speed? What do I say about my speed equation? Do I say my distance equation equals 83, or do I say my speed equation equals 83? Which one is it? The jet has to reach a speed of 83 meters per second. This means I use my speed equation and I put it equal to 83. Does that make sense? Speed equation, answer is 83. So you say 4t plus 3 equals 83. It then asks you to find after how many seconds will the jet reach the speed. After how many seconds is a time question. A time question is the letter t. So we should find t on its own to find the time, right? So what happens then? Bring the 3 over to the other side. Turns into -3, which turns into 80. And then t, 80 divided by 4. Anybody? 20. T equals 20. We've now done part 2. Now we're on to part 3. How far is the jet from the marker at this time? How far is the jet away from the marker? How much distance has it covered after 20 seconds? Anybody tell me, do I use the red box or the green box for a how far question? How far is distance? I must use the distance equation. Is the distance equation the red box or the green box? Red box. So what do we replace t with? Replace t with 20. And what will we get? It's going to be 40 plus 80 plus 3,200. 1,240 meters. Okay, is that alright? 1,240 meters. Find the acceleration of the jet. What did I tell you earlier about the acceleration? Second derivative. Differentiate this part. How do you differentiate that? Anybody tell me? It just turns into d2s dt squared, and most people are telling me 4. This means that the acceleration of the aeroplane is always 4. Never changes. Okay? If I had a t in there beside it, the acceleration would change depending on what time it is. You'd have to put in a t value to find the acceleration at any time. But because there's no t value in this, there's nothing to sub in, therefore the acceleration is always 4. We'll try one more of these guys. Then, sorry, 2 more, and then I'll let you at them, okay? What we have here is a distress flare is fired vertically upwards. The height h in meters of the flare above the ground is given by h equals 20 plus 90t plus 5t squared. Even though it says h, what is h? Height is a form of what? Distance. So the rules of the last question obey to this question as well. So that means that the first derivative will be equal to, anybody tell me? Speed. Second derivative will be acceleration. So because we identified it's a distance question, all rules remain the same. Is everybody following this? Okay. Okay, here's what we're going to do first, okay? First of all, what happens usually when you fire a flare into the air, lads? It goes up, and then it goes on its way back down again. So it reaches a maximum height, and then it falls back down again. Everybody agreed with that? Okay, here's the second thing, okay? So what it says is, find the height above the ground at which the flare explodes. When does it explode? At t 7 seconds. 7 seconds is not, maybe it might not be the maximum height, but we know it's guaranteed to explode 7 seconds after firing it. So do we replace what letter into what equation? It wants the height. What is the height equation? So 20 plus 90 times whatever t is minus 5 times whatever t is squared. 20 plus 90 times 7 minus 5 times 7 squared. Can somebody try that out on the calculator for me? 20, just double check it for me, plus 630 minus 5 times 7 squared. What you get? 405. Shh. Excuse me. Shh. The height is 405 meters above the air when it explodes, okay? Find the speed of the flare when it explodes. Mick, how do you get the speed equation? How do you find the speed equation for this? Question 2 says find the speed. What's the speed equation? That's the height equation. How do you get the speed equation? No, it's written down here. See the speed? What does that mean? Differentiate once, okay? So when we differentiate once, what do we get? We get the h to t, and what will that equal? Differentiate 20, you get? Yeah. 90 minus 10t. Now this 90 minus 10t is an equation for your speed. It always gives you your speed. After how many seconds do we want to try to find the speed? It's when it explodes. How long does it take to explode? 7 seconds. T equals 7. So put that in. 90 minus 10 times 7. 90 minus 10 times 7 is 20. Now, guys, excuse me for a second. 20 means it's still going 20 meters per second into the air. Because it's still moving upwards, does that mean it's reached its maximum point yet? No. So basically, it explodes before it reaches its maximum height. So we know it's 20. If the flare failed to explode, find the greatest height above the ground it would reach before falling back down. When an object reaches its greatest height, whether you be throwing up a tennis ball or whether you be kicking a football in the air, when does the tennis ball momentarily stop, or when does the flare momentarily stop in the air? And what happens to its speed? Speed becomes 0. dH dt equals 0. So which equation do we put equal to 0? The red box one or the blue underlined one? Speed. Remember, your speed is 0 because at the top your speed is 0. Red box equals 0. So what we say is that this one here is your 90 minus 10t. It equals 0. 90 therefore equals 10t. T equals 9. This is also known as your maximum point, or your maximum occurs 9 seconds in. Now, here's the problem, guys. This maximum, remember I was telling you about the N-shaped curve we have? Okay, it's an N-shaped curve. This is the maximum height. But we don't know the Y value, we X value. We know after 9 seconds it reaches its maximum height. That's not the answer to the question. The question is, what is the greatest height? We found the time it takes for the greatest height, but we haven't found the greatest height yet. Which equation gives you the height? The very first equation. What do you need to do with that very first equation? 9 for t, and when you put in 9 for t there, what happens? What happens there, guys? 425. Thank you very much. H equals 425 meters. Now, do you want a really, really easy way to figure out exactly what's going on? Really, really easy way. The really, really easy way to figure out exactly what's going on is you immediately, once you see this, okay, you go to your table, you enter it all in. Instead of t, you use what's it called? You use x, okay. And then once you do this, and you're surprised how many marks you pick up just for doing this, okay. Starts at 0. Let's say end at 15. Let's give it a big long time frame, okay. Now look what happens here, guys. Are you ready to read this? At 0 seconds, you're 20 meters above the ground. So when you fire your flare, you're actually 20 meters into the air. After 1 second, the flare reaches 105 Mach. After 2 seconds, it's 180 meters into the air. You keep going upwards. Just keep going, keep going. After 7 seconds, it's 405 meters above the air. We already had that earlier on, didn't we? After 7 seconds, the flare exploded, didn't it? Hence giving us a 405 meters above the air. Keep going. After 8, it's 420. After 9, it's 425. How will we know that 425 is the maximum? Go one more down. After 10 seconds, it drops back to 420. So we automatically now know that 425 is going to be its greatest height. This is a backup plan if everything else fails for you in an exam. Okay? Then you can keep going backwards until it hits the ground again to find out how long it's in the air or whatever you want. Okay? But you can see that the calculator alone gives you so much information without actually even doing anything. Okay?
How can we use the calculator?
So, question 4, okay? Not all questions have to be distance time related, okay? So an example would be the polar bear species in hundreds of an endangered species was monitored over T years. P is modeled by the equation T squared minus 6T plus 18. We already know that's a U-shaped equation because it's a plus x squared or a plus T squared, okay? Now, let me explain what's going on here. It says that it's modeled from 1 to 6. Now, what 1 to 6 means is this. If you go up to 1, that's where it starts, okay? And if I look at my calculator, this means at t equals 1, there's 13. Remember, it's in hundreds. That means 1,300 polar bears in the wild, okay? Then you go down to 2. 2 is located here. Go back to your calculator. After 2 years, there's 1,000 polar bears in the wild because it's 10 times 100. After 3 years, there's 900. We can see that 900 is the lowest they've been. So 3 years, there's 900. 4 years, they're back to 1,000 again. And then 5 years, I think we're back to that number I had at the start. 5 years. After 5 years, they're back to 1,300. And then finally, after 6 years, they're back to 1,800. So you can see that population growth can be modeled on a quadratic equation, okay? Now, what happens here is, what it's saying is, find the P to T. Now, the P to T is quite easy to do. It's just 2T minus 6. Okay, no big deal there. Paying attention, guys? 2T minus 6. Find the smallest population of the species, okay? Now, let me explain what the P to T means. The P to T means, do you remember the last question we had distance, okay? And when you differentiate it once, it's velocity. Another way of saying velocity or speed, do you remember the first derivative of speed, lads? Another way of saying speed is, how quickly is the distance changing? That's another way to say speed. So in the way to say this one is, how quickly is the population changing? That's what the first derivative means. How quickly is the population changing? Now, when it stops changing, is its turning point. So if we put the P to T equal to 0, that's when the population stops decreasing. Do you remember, it's negative on the way down and then positive on the way back up. So when does it stop changing, okay? So it stops changing when 2t minus 6 equals 0, 2t equals 6, t equals 3. See it there at the bottom, 3 seconds, 900 in the population, okay? Find the smallest population of the species. We just determined that it's when t equals 3. So what you could do is you could replace t back into your original equation. P equals 3 squared minus 6 times 3 plus 8. The answer gives you 9. But please remember, 9 represents, it says up here at the start, 9 represents the population in hundreds. So it's actually not 9, it's 900. Sean, you have a question? Next part after that, guys, is calculate the rate at which the population is grown after 4 years. This basically wants to know, what is the population, it's not, the question is not what the population is, it's how fast is the population increasing. We know the population is 1,000, that's not the question. The question is it increasing, okay? Now remember, increase is measured by slopes. We got to find the slope at t equals 4. So let's find the slope at t equals 4. The slope, the equation for slope is 2t minus 6. Replace in t equals 4. 2 times 4 minus 6, anybody? 2. That's not 2 though, it's 200. You are currently increasing by 200 polar bears a year at that point in time. Yes?
Where'd you get 4 from again?
It says in the question, 4 years, t equals 4. Okay. This question is, an automatic valve controls the flow of gas. In an experiment, the flow of gas varies with time as given by this equation. What type of equation is that? What shape is it? More so. Anybody tell me? It's an N-shaped. The N-shaped graph will look like this, okay? Now, because it's a time question, what does that mean about the t value? Where does it start? t equals 0, and then we don't know how far it goes. So to accumulate a lot of information about what's going on before you even begin, I suggest you just enter that into your equation and you figure out what on God's green earth is actually going on here, okay? So you go x squared, start at 0, go as far up as 20 seconds even. I don't know how far to go up yet. Just take a big number, okay? Now, look at what happens. Automatic valve controls the rate of flow. So you're talking about gas. You're talking about how much gas is entering the experiment. Would everybody agree with that?
Yeah.
Okay, so here's what's happening. The gas at 0 seconds, no gas is in the experiment. After 1 second, there's 7 units of gas in the experiment. Keep going upwards. When does it reach its maximum value? After 4 seconds, there's 16 units of gas in the experiment. Keep going downwards. When does it reach 0 again? After 8 seconds, it returns back to 0. So it's very easy. 0's here, 8's here, and t equals 4 is at the very top. Everybody understand that? So from 0 to 4, you're on your way up. The amount of gas is being increased. After t equals 4, the amount of gas is on the decrease. Does that make sense? Yeah. Okay, perfect. Right. So you've learned a lot just from using your table function in your calculator. Now you're in a position to answer some questions. Okay. Differentiate it. So first question is differentiate it. So what happens when we differentiate it? What do you say? 8 minus t. 8 minus 2t is the equation of the slope. It will tell me the slope at any point on this graph. Everybody got that? It will tell me the slope for any t value I want. Okay? Next thing, once that's done, find the rate after 6 seconds. Now guys, excuse me, 6 seconds. Is 6 seconds on its way down or its way up? From 0 to 4, you're on your way up. From 4 to 8, you're on your way down. We're expecting a positive or negative answer. If you're on your way down, it's a negative answer. We're expecting a negative answer. 8 minus 2 times, anybody? 6. 8 minus 12 equals minus 4. It says centimeters cubed per second. Okay? So, it's minus 4, okay, is the answer for this one. The time at which the rate of flow is a maximum. We already know this, don't we? T equals 4. But we have to prove that t equals 4. What happens to your slope when you're at a maximum? Slope is 0. So this equals 0. Bring the 2t over to your side. And then t equals 4. While you don't get full marks for the calculator pretty much tells you if you're right or wrong with what you do. We know that it's after 4 seconds. After how many seconds will the flow be equal to minus 4? Okay, when will it be equal to minus 4? Okay? Sorry guys. With the rate of flow, okay, rate of flow. Okay guys, here's what we're going to do guys. Rate of flow is dr dt, says it there. Okay, rate of flow. So, dr dt equals 4 minus 2t. Oh sorry, it's 8 minus 2t, excuse me. 8 minus 2t. Now guys, what does it want 8 minus 2t to be equal to? What does it want your slope to be equal to? Minus 4. Bring the 8 over to your side. Minus t equals minus 4 minus 8. Minus 2t equals minus 12.
T equals minus 12 divided by 2.
Yeah. 6. Okay. Mick. Next one. When it equals 2, what do you do then? When your slope equals 2. Are you on your way up or your way down? If your slope equals 2, are you on your way up or your way down? You're on your way up. So you're expecting an answer in between 0 and 4. Okay. What you do to solve this equation, Mick?
Me?
Yeah.
Bring the 8 over.
Yeah, and what you get?
Minus 2t equals 8 minus 2 minus 8.
Yeah, minus 2t equals?
6.
Minus 6. 2t equals 6. What does t equal?
Minus 3.
Plus 3.
Sorry.
As predicted, your time value is in between 0 and 4. Okay, guys.